Okay, we'd like to show you how to produce a stem and leaf plot in SPSS, and more importantly, how to interpret it in SPSS. As we'll see, sometimes the interpretation is not as straightforward as we'd like it to be. I have a small data set here, x, y, and z. I have my data set's a little bit longer for x, and there's a reason for that, to provide a little more variability on that data. How to generate the stem and leaf plots. I'm going to go up to Analyze here. I'm going to go to Descriptive Statistics, and I'm going to choose Explore, and that opens up the Explore window. I'm going to enter x, y, and z, and that's all I need to do. I'm going to request both statistics and plots, even though we're only using the plots for this example, and we'll just ignore the statistics. But if you just wanted the plots, then you would click here, and that'll include some other plots as well, not only stem and leaf plots. So we're ready to go. Here's my output. I'm going to bring this a little bit closer to the actual data so we can compare it as we interpret it. There's my first stem and leaf plot. Oops. Now, the first thing to realize in SPSS is that the stem and leaf plots can be a little tricky to understand. So let's look at this plot. Now, if you look at this plot, does it look at all anything like this data here for x? And the answer is no. You have a whole bunch of zeros. You have 1, 2, 3, 4, 5. So your first glance your first interpretation may be that you've done something wrong, but you haven't. The key to interpreting these plots is to look down at the stem width. And that says everything you need to know in terms of how this plot is going to turn out. This stem width says 1.00. That means that the width of the stem is at the unit. Now remember that we have, before the decimal place in any number, let's take this number here just as an example. This reads 1.00. This 1 is the unit. If I put a number before the 1 right here, that's the 10. If I put a number before the 10, that's the 100, and then the 1,000, etc. So when SPSS is saying that the stem width is equal to 1.00, it is saying that the stem width is equal to the unit position. So when I look at this first line of the plot, I see that there's a frequency of 1, and that's fine. But the stem is equal to 1 and the leaf is equal to 0. So what does that correspond to in this data set? Well, it corresponds to the number 1 right here, because the stem width is equal to the unit. And when I look at the 1 here, this is the unit. There's nothing before it. There's no 10 before it. There's no number before it. So the way to interpret this first line is that this is equal to the single 1 in the data. How about the next line? It's the same idea. This is not equal to 20, just like this was not equal to 10. Otherwise, the stem width would be equal to the tens. But since it's equal to the unit, this is reading that I have 1, 2 in the unit, a single 2. If I verify in the data, I do. I have a single 2. Same idea for the next line. Be very, very careful. This does not mean I have 4 30s. This means that I have 4 3s, again because of that stem width. And if I look over here, you'll notice those 4 3s stacked up, etc. for the other numbers. So that's how that works. So make sure that when you produce the stem and leaf plot, and if it doesn't look anything like you thought it would, doesn't mean something went wrong. It means that you need to focus on the interpretation, and you need to check out that stem width to know exactly what you're looking at. So much for x. Let's go to y. There's the box plot. Stem and leaf plot for y. Now I've made this data a little bit different to kind of confuse SPSS a little bit, to kind of generate a different plot so that the stem width is not equal to the 1. In this case, it's equal to the 10. Now if I look at my data, I notice I have 2, 4, 0, 1, 5, 6, and then a whole bunch of 10s, and then 140. So what does this first line represent? Well, 0, 0, because the stem width is equal to the 10s, this means that I have a single 0 in the data. And indeed I do. There's my 0. The next one is 0, 1. This means that I have a single 1 in the data, and indeed I do. And so on for the rest of that line. What does this second line represent right here? This represents 0, 5. So I have a 5 in the data, I have a 6 in the data, and if you check it, I do right here. And here's the next one. I have 4 tens, 1, 0, 1, 0, 1, 0, 1, 0, and there are my 4 tens right there. And then SPSS lists this outlying score, greater or equal to 140, because that's an extreme score. So it's not even going to try to really list that. It's just telling you you have 140 is considered an outlier in this data set. Okay, so that's how you read the stem and leaf plot for y. Notice how the stem and leaf plot for y is different from the stem and leaf plot for x. And that is because of the structure of the data where I have either unit positions, tens, or hundreds. Let's go to z. Now look at the stem and leaf plot for z. If you thought x and y were confusing, you're really going to love z. Now, first look at the plot. Does it look anything like this data here? I have a 16, 8, 5, 7, 5, 4, 15. My goodness, where are those numbers in here? Looks like they're not even in here. Again, the key is to look at the stem width. There's my stem width, 100. The width of the stem is 100. So here's how it works. When I look at this first number, 0, 0, I know the width of each leaf is equal to 1 case, so I know there's not any doubling of cases here. I know that this 0 corresponds to one case, this 0 here corresponds to another case, etc. But what does 0, 0 represent? Well, because the stem width is equal to the 100 position, what could this mean? Well, that means that the 0, 0 corresponds to any number for which I don't have 100 or a 10 position. I'm going to say that again. The 0, 0 corresponds to any number in my data set for which I don't have 100 or a 10 position, but only have the unit position. Well, let's look at 16. What positions are filled? Well, the unit position is filled with 6. The 100 position is filled with 1. So that is not represented on this line. How about 8? The unit position is represented. The 100 position is a 0. By implication, it's a 0. And the 10 position is also a 0. I should have said that a little bit differently. I should have said unit, 10 is 0, and then 100 is 0. So this number here is actually 0, 0, 8. Okay, this is 0, 0, 8. The way SPSS is interpreting it is saying that because you have nothing for the 10 and the 100 position, it's going to code that as 0, 0. It's not including the 8 because the stem width is equal to 100. Okay. Similarly for 5. 5 is also in this first particular row of data. The 7 is in here as well. So my first 4 numbers, 0, 0, 0, 0, or first 5 numbers rather, 0, 0, 0, 0, 0, that is made up of these lower numbers here, 4, 5, 5, 7, 8. How about these 2 1s here? Again, this is not 0, 1, 0, 1. This now corresponds to the place where I actually have a 10 position. Well, what places do I have a 10 position? Well, I notice I have a 15, and I notice I have a 16. Therefore, those numbers are represented. So this number here, 0, 1, actually corresponds to 15. The next number, 0, 1, corresponds to 16. Again, this is because of the stem width. Tricky to understand? You bet. Let's move to the next line. 0, 5, 0, 9. Well, what could that possibly represent? Well, when I look at my data, I know I've taken care of all these numbers. This is saying that the 5 corresponds to the 50. So 0, 5, 0, 5. The last 0 in the 50 here, so the unit position in the 50 is not represented on this line because of the stem width. So SPSS is comfortable in just coding this 0, 5 and having us know that this corresponds to the 50. Now you can't really tell. You don't know what this number is. You do not know if it's 50, if it's 52, 53. You have to actually look at your data to know what it is. This stem and leaf plot is not telling you that unit position for the 0, 5. Let's go to the next one. What does the 9 correspond to? Same idea right here. That's the 0, 9, so that's the 99. Again, all you know is that you're in the 90s. There you don't know if it's 91, 92, 93. You cannot tell that by looking at the plot. And finally, for the last one, well, again, this is not 10, 10. Now we have our hundreds position here. So this is 100, then 101. So as before, all we know is that we're starting off with that 1. We don't know what the other numbers are until we actually look at the data. So there's the stem and leaf plot for Z. I've shown you 3 stem and leaf plots. They're not as straightforward as we'd like them to be. Sometimes we advertise stem and leaf plots in saying that these are great plots because you can actually read off the points in your data set by looking at the plot. But as we've seen, if your data set gets a little bit complex and you have a pretty wide spread of data with some unit positions, tens and hundreds, SPSS will do its best to produce a plot for you, but you're not going to be able to really read that much off of it. And you will have to look back at your data to find out what exactly those values are. The great thing about the stem and leaf plot, on the other hand, is that it'll always give you some kind of shape. So the skewness of this distribution is the skewness of it no matter what the stem width is. So this is kind of nice to see. Same thing for the other ones. So Y, you still get that shape that you're looking for. When you look at a stem and leaf plot, it gives you that overall summary of the distribution, and the same idea for X. So that's how you produce and interpret stem and leaf plots in SPSS.